Good afternoon, students. Welcome to Dr. B.R. Ambedkar Open University. Today we are discussing BSc 6th semester core subject estimation of testing of hypothesis. In this topic we are discussing concept of testing of hypothesis and problem based Neyman Pearson lemma. It is useful to your end semester examinations as well as your work also. Here today two experts in the studio to discuss and explain this subject. I will introduce my two experts here. From my left side, Professor N. Raju, Professor of Mathematics and Statistics, Gurunanak Institution Technical Campus, and another one, Dr. M. Ramesh, Associate Professor, Department of Mathematics and Statistics, Matsuri Engineering College, Hyderabad.
Sir, both of you welcome to our university. In this unit,
we are discussing about simple hypothesis, composite hypothesis, null hypothesis, alternate hypothesis, and errors, type 1 error and type 2 error also we can discuss here. And also on that basis of the problems based on Neyman Pearson lemma, where it will be used in the Neyman Pearson lemma. The two experts will explain for you. In that likely hot function of the sample and a problem on NP lemma, and also very useful the critical region also they will explain in this topic. Students, I request you, it is useful to your further studies. Any doubts, clarifications, please call me this number for your doubts. Note down the number 04023680456. I am repeating again 04023680456. Raju sir, so what is the concept of hypothesis and lemma, how it is useful to the students, and also explain about the simple null hypothesis, how it is useful to our students?
Yeah, exactly, Vijaya Kumar. So now I am going to explain step by step procedure. Actually, it is a testing of hypothesis is an important statistical tool used to verify assumptions and make reliable decision using sample information. If you have any information, we will take some decisions whether your data is correct or wrong. So based on that assumptions, we'll make some certain decisions that is very useful for us. So in this video, we'll discuss few techniques, concepts, how it is useful for the students. It is a step-by-step process. I will explain in detail. Concept of now I am going to discuss first topic is concept of hypothesis. So what is hypothesis actually? Generally it is hypothesis means is an assumption. Okay, so now I'm statistically I will define one most important definition. A statistical hypothesis or simply hypothesis is an assumption about parameters of the distribution, and sometimes it is also concerned the type and the nature of the distribution that is we want to verify. For example, the average height of soldiers in Indian Army is 165 centimeters. We'll define this is based on the region or overall. So which region we'll consider, all those things will again. So based on the sample data, we'll decide that things. Okay. So before that, we'll discuss simple and composite hypothesis. What do you mean by simple hypothesis? What do you mean by composite hypothesis? So these two are very important. These two words play the vital role while discussing any testing of hypothesis. First, we're going to discuss simple hypothesis. So what is a simple hypothesis? According to definition, if a statistical hypothesis completely specifies the distribution, it referred to as a simple hypothesis. For example, consider the hypothesis about the mean lifetime of electrical bulbs. For example, so I'll define average life is equal to 1000 hours, for example. Here the population mean is specified as exactly 1000 hours.
Sir, you are explaining about the mu is equal 1000 hours you are telling.
Yes.
So 1000 hours is the maximum or minimum?
That is the maximum hours. That is the maximum hours. Okay. So maximum hours, based on that means we are assuming that there is a statement which tells about simple statement this is. Okay. So based on the population parameter. So mu is equal to 1000 hours. Okay, that is my simple statement. Okay, so now we're going to discuss another assumption also we have, that is composite hypothesis.
If does not specifies the distribution completely, it referred to as composite hypothesis. Previous one is it's specifically specify the distribution. That means hypothesis mu population mean value is equal to 1000 hours. But composite hypothesis, it's corresponding to composite hypothesis, mu is not equal to 1000 hours. Again, there is a one question is there arise in your mind, whether it is less than or whether it is greater than. So these are the two alternatives. That is why we can say this is composite hypothesis. So these hypotheses are composite hypothesis because the population mean cannot make many possible values, because here one is mu is not equal to 1000 hours, either mu is greater than 1000 hours, either mu is less than 1000 hours.
Yes, sir. Raju, sir. The simple hypothesis and composite hypothesis are both are not same. That is a difference between simple hypothesis is equal to 1000 hours. In composite is not equal to exact opposite. Then only it should be applicable.
That is why. So previously the distribution is specified. Here the distribution parameter is not specified completely. That is why previous one is simple statement. Now it is composite statement.
Yes,
maybe
sir.
you are understanding this concept. So now. So make generally the concept of hypothesis, before discussing these previous concepts, now we are discussed two important topics. One is null hypothesis, another one is alternative hypothesis. So null hypothesis means a definite statement about the population parameter for applying the test of significance is called null hypothesis. A null hypothesis is denoted by a symbol H0. So that means it is a simple statement about the parameter. So one more, according to Professor R.A. Fisher, he is known as a well-known statistician. He is a father of statistics. So well-known mathematician, statistician, is defined one important definition regarding null hypothesis. Null hypothesis is the hypothesis which is tested for possible rejection under the assumption that it is true, according to Fisher. So I'll give one example in that case also. Let mu is equal to population mean. This is standard notation. Mu naught is equal to specified hypothesized mean. That means collected mean. So according to null hypothesis, mu is equal to mu naught. That means there is no difference. What I said according to definition, there is no difference. That is a simple statement about the parameter. So for example, a teacher wants to know if a new study method improves test scores. For example, I would like to test my students' test scores are improved or not. So I will conduct one test. Then after that my assumption is simple assumption. I will define my H naught. H naught means H0, null hypothesis. The new study method does not improve the test scores. That is my first perception. That is my null hypothesis. That means the new study method does not improve the test scores.
Raju sir, it is a null hypothesis. We are discussing about mu is equal to mu naught. But mu A and mu B we get mu A greater than mu B. What is that condition, sir?
That is, we'll discuss one by one. Because
okay,
that is the next step. That is a simple alternative. We go for alternative. That is when we'll go for that one, that is a composite statement. You are asking composite. Yes. So in that composite case, we can go for either greater than or less than, either not equal. That is situations may be arise in this. We'll discuss in detail in the next slide. So alternative hypothesis. Any hypothesis which is complementary to the null hypothesis is called an alternative hypothesis. Okay. So previously we said simple statement. Hypothesis, null hypothesis stated about simple statement about the parameter. Okay. Now alternative hypothesis is represented by notation H1, a symbol H1. So H1 means again there is a three possible combinations. Okay. That means the distribution is not specified completely. That means mu is equal to mu naught. In that case, we can apply the two-tailed test. So if mu is greater than mu naught, will apply right tail test. If mu is less than mu naught, we can use left tail test. These are the possible tests. Okay. So for example, previous assumptions I already used. So H1, what is my alternative hypothesis? Null hypothesis H0. What I said, the new study methods does not improve the test scores. That is the previous assumption. That is the simple. Now my alternative assumption is, in that case, The new study methods thus improve test scores. That means again question mark here. So that means, so there is a two possible combinations. Either mu is not equal to mu naught, either mu is less than mu naught, either mu is greater than mu naught. These are the possible alternative hypothesis. For that, if you discuss the alternative hypothesis, we are apply the two-tailed test. Already I said, that is, if it is not equal, we can apply the two-tailed test. That is, so you can check the red color here. Test shaded is a two sides test. That means one side is alpha by 2, this side is left side is alpha by 2. This alpha by 2 plus alpha by 2 is alpha. So remaining region is total area of the probability is always 1. Already we knows that. So 1 minus alpha is tells about non-rejection region. Alpha is the rejection region and 1 minus alpha is the non-rejection region. That means acceptance region. So what is the rejection region here? Alpha by 2. Two sides we are going to test. This side is left side is alpha by 2 and the right side is alpha by 2. Okay, these two are rejection regions. So this, if you are taking your test comes under not equal case, we can apply the two-tailed test now.
So Raju sir, both we are taking two sides, we are discussing, that's why we are taking two-tailed test.
Two-tailed test. So both sides, left side and as
right
well
side.
as right sides. Okay. So next one more test we have, that is either left, two more possibilities are there now. Another one is right tail test. In that right tail test, you can check total is rejection region, that shaded area is alpha only. Previously we are taking alpha by 2. Alpha by 2 is left side, alpha by 2 is right left side. So now we are taking that is why we can, this test is known as a right tail test. Okay. So in that case also, we can take the C is a critical region. What is the end point? So rejection region and critical value, and shaded area is tells about rejection region, and leftover region is tells about acceptance region. Okay. So total probability already you know that 1 minus alpha. If you know the rejection region alpha, then remaining region is known as a acceptance region. That is 1 minus alpha. So this is if you are taking the right tail test, you will make a decisions based on this critical value. So next one more tail test is we have, that is left tail test. In that left tail test, we can take the left tail rejections. Here also rejection is alpha, shaded area is alpha, then 1 minus alpha is there, that is a non-rejection region. Okay, so left side tail test, then C is represented as a critical value. So based on this alpha, we are going to accept or reject. We are testing this alpha is tells about level of significance. At what level we are going to reject your null hypothesis. So that is depends on these three parameters. First one is what? Two tail test, left tail test and right tail test. So maybe these three are the important tail test. These are the plays a vital role in while making a decisions. Okay. So here to maybe you are after going this hypothesis, there is some common errors we have in testing up hypothesis. Okay. So that is decision taken. This is the dichotomous table I will show in here. So that is the errors in testing up hypothesis. There is a possible errors. Few errors are occurs while making a decisions. So here already I said H0 is represented what? It's a symbol for what? Null hypothesis. What is H1? H1 is H0. H0 is the H0 is, so based on the null hypothesis, we are going to take a certain decisions. Okay. So actual situation is what? H0 is true. H0 is false, down one. So reject H0. So H0 is true. When we reject H0, this is known as a type 1 error. We are making a committed error. This is H0 is true, but we reject H0. This is treated as a type 1 error.
Again explain sir, it is a lengthy explanation. So type 1 error is not accepted, not rejected. How it is error?
Error means, so here H0 is true. H0 is true, but we are rejecting. So my statement is right, but we are rejecting my statement. Yes. That is which type of error?
The type 1 error. Exactly.
So it's a false information. This is a
false information.
So H0 is true. Accept H0. My statement is correct. Yes. I accepted. then this is treated as what? Correct decision.
Correct decision. Correct.
So correct decision, there is no error. So that is the one thing. So coming to another alternatives also we have, that is H0 is false.
Exactly.
But we reject H0. H0 is false. My statement is false.
False.
We rejected my statement. You rejected my statement. That is what? Correct decision only. Otherwise, one more error will occur. What is that? H0 is false.
Yes.
Accept H0. If you accept H0, then it is a type 2 error.
Type 2 error.
So H0 is true. When we reject H0, there is a type 1 error. H0 is false. When we accept H0, then it is a type 2 error. Next slide. So in detail, according to probability, we'll discuss what is a type 1 error and what is type 2 error. There are two possible types of errors in testing of hypothesis. One is type 1 error, another one is type 2 error. Okay. So probability of rejecting H0 when it is true. Already we discussed. Just now I explained this. Reject H0 when it is true. So is equal to alpha. What we say alpha is nothing but level of significance. We'll discuss in detail what is the level of significance, what is use of level of significance. This is a committed mistake, type 1 error this is. Next, type 2 error. What is a type 2 error? Probability of accept H0 when it is wrong.
Exactly.
So it is represented by a symbol beta.
Now just you are told, sir, earlier the
Yeah.
accept when it is wrong, we can take that value.
Yes, exactly. So type 1 error and type. I hope you are understand everyone. Okay. So already I say this is alpha. Alpha is what? Level of significance. This level of significance is play the vital role while making a decision. Final conclusion of the any statistical test.
So
Okay.
what is the definition of LOS, level of significance?
Level. So I am going to. The probability of rejecting a true null hypothesis is called a level of significance or size of the test. It is denoted by alpha. Previously we defined type 1 error. Type 1 error is represented by which notation? Alpha. Rejected one only na. Type 1 error means what? Rejected. H0 is true, but we reject H0. So what is the definition it tells about your level of significance? The probability of rejecting a null hypothesis is called the level of significance or size of the test. It is denoted by alpha. So alpha is equal to what? Probability of type 1 error. What I said just now, type 1 error. That means probability of rejecting H0 when H0 is true. So most commonly used level of significance, LOS, simply we can as a LOS. Level of significances are 1% or 5% or 10%. So means what is the meaning of alpha is equal to 1%, 5%, 10%? Already what is the type 1 error? Rejecting na? So if I conduct the test 100 times, 1% chance is going to reject my
As a
test.
statistician is willing to accept that error.
That error we are willing to. Yes. Alpha is equal to 1% or 5% or 10%. We are willing to accept this hypothesis.
So Raju sir, we are using only 1%, 5%, 10%.
Yes.
Suppose in LOS, they did not ask in the examination that you can do the LOS
Yeah.
1%. So
Yeah.
what the student will take in the examination, or then 1% or 5% or 10%?
So based on the availability of data, based on the importance of data, if it is, we can take the example for medicine related information. We don't go for beyond more.
Exactly.
It's a costly. So then we go for only 1%. 1%. Either if it is a goods, electrical goods like that. So type 2, so 5% may be accepted.
Yes.
Either some few more based on the availability of the items, availability of the resources, and availability of the what is the cost of the item, cost of the equipments also based on that. So whether that validity, reliability is important. That is why we are going to test, as a statistician, I am going to test my rejection at percentage or 5% or 10%.
Because they have to solve their problem, or they are taking that one, we have to maximum take the 1%.
Yeah.
Otherwise,
So-
you can take the 0.05%.
actually-
we can take that statistical
Yes,
table,
yes.
and that values you have to produce that.
Everyone wants to good material. Why don't you for rejected ones?
Exactly, sir. Exactly.
Yes. If I going to test, I purchase by a few bulbs. 10 bulbs I purchase. After purchasing, 5 are failed. What is the use of that?
Yes, sir.
Yeah, that is it.
Exactly.
So we have
Exactly.
to use some real time examples also. So if 100% is accurate, that's better for us.
Exactly.
So that is that testing is very, very important as a this. After that, we are going to test one more important test is there, power of the test. So power of the test means already we represented type 2 error. Type 2 is represented by which notation? Beta. Okay. If beta denotes the probability of committing type 2 error, then 1 minus beta. 1 minus beta means earlier one is probability is type 2 error. What is the type 2 error definition? It is a rejecting only. Both are rejecting.
Exactly.
But 1 minus beta is equal to probability of rejecting H0. H0 is false. Is called power of the test. So this power of the test we can use while discussing the Neyman, Pearson, Lemma concepts.
Exactly.
The power of test is very useful. Whether test is best critical region, we should find the best critical region based on this power of the test. It indicates the probability of taking a correct decision. So that is the power of the test is very useful test. Okay. So this is one of the important aspects. So what is the 1 minus beta is tells about the power of the test. If you know the beta value, 1 minus beta is tells about your power of the test. So now one more important parameter is test statistic. Okay, to test whether the null hypothesis setup should be accepted or rejected. So whether our data is accepted or rejected. We will say just we assumed only.
Yes.
But we need to verify whether our data should be accepted or rejected. So in that case, we use appropriate test statistic. For that, to test whether the null hypothesis setup should be accepted or rejected, we use a test statistics which is the based on appropriate probability distribution. So now, actually in the test statistics, statistical tests are classified into two types based on the size of the sample. So how to identify our test statistics based on this sample size. So there are two sample size according to statistical test. We are applying. We should know two sample sizes. One is small sample size. Another one is large sample size. Okay. When we say your sample size is large, when we say our sample size is small. So based on that information, we'll apply the suitable test statistics. So for example, if the sample size n is greater than, sample size is represented by notation small n is greater than or equal to 30, it is called as a large sample test. Important key point for everyone. Your sample size n is greater than or equal to 30, it is called as a large sample test. If the sample size n is less than, I am not using the less than or equal to, already I use the greater than, so greater than or equal to 30. So n is less than 30, it is called as a small test. Okay. So there is a two sample tests, large and small sample test. So based on this, we'll use the appropriate test. Now I am going to discuss small sample test. These tests are generally assume that population follows a normal distribution. Okay. Under this category, small sample tests are as follows. Generally, we know that three important tests we can use. One is students t-test, generally known as a t-test. Second one is f-test, and third one is chi-square test. Under when we use this student t-test, used for comparing means. So here again, t-test we can apply the three ways. Comparison of single mean, then it is called as a one sample t-test. If you want to compare two sample data, X series and Y series available, in that case we can apply the two sample test. Again, paired comparison t-test, that means before and after data, similar data, same family of the data, we can consider before and after based on certain conditions. Differences. That means one sample t-test, comparison of two means, that means two sample t-test and paired t-test. These are the student t-test. Student's t-test. Why? It's a pen name of the
scientist
author.
name.
Exactly. That is why he given to us a name is student's t-test. Okay. So this is the
so
first
we can
test.
take the different views from the student t-test. There were three modules we are taking one sample, two sample and a paired test only, then we can taking the good result.
Yes,
So,
yes,
test for
exactly.
single mean, difference means
So
purity test.
that is
Yes,
a
sir.
level of so first one is level of significance. We can find the test of significance between the one main, difference between the two mains, and the pair comparison
test.
t-test.
Then only accrue the good result.
Good results. Based on the data, we can go for the which one is better one, which one is appropriate one.
Exactly.
We can't apply the every data to. So before and after data is there. I would like to apply the two sample test. It's not a suitable test.
So student t-test means which data is applicable, we have to produce that
Yeah.
test on
Moreover,
that only.
moreover, your sample size less than 30 only. Then we can apply t-test based
Exactly.
on the
That is a-
availability of the data.
That is the most important for the less than 30 we have to take.
Yes, that. Coming to second one is sometimes means are not provide accuracy results.
Exactly.
In that case, we can go for variance.
Suppose equal variances.
Equivalent. So now we can use the F test.
F-test.
F test is one of the most powerful tests. So use it for comparing the two variances, which will provide us very good results, accuracy results.
Exactly.
Okay. Now coming to third one is chi-square test. So use it for variance and goodness of fit. We'll estimate the fittings, goodness of fit of the data. So
Raju
this
sir,
is the
Raju
difference
sir,
between-
chi-square test, what is the definition and where we can use, sir?
Yeah, so for example, I want to check whether the education it depends on the nature of the studies. That means either female students or male students.
Exactly.
If you have to check the whether the education depends on sex, that means either male or either female.
Exactly.
So this type of data, categorical data. So in that case, we can apply the chi-square test.
Even though observed and expected
Observed.
differences.
So in that case, observed
also-
values,
Observed and expected frequency also we have to check.
So we should expect it. We should find that values.
So we can apply the chi-square test, observed and expected frequency should be the
Should be
same.
the same.
So then it is
Yes, for that time also we'll go for the some test, goodness of fit.
Exactly.
Okay. So second category. First one is small sample test. Now we are going to test large sample test. So when we say the given samples are large, already said, what is the sample size? So n is greater than or equal to 30, this comes under large sample test. So in that case, Z test is a suitable test. So Z test is a statistical test used to determine whether there is a significance difference between sample and population means when the sample size is large or the population variance is known. So in that case only we can apply the large. So generally the large sample tests are as follows. Okay, Z test for single mean, comparison of single mean, Z test for difference of two means, Z test for proportion of single mean, Z test for proportion of two means, and Z test for difference of standard deviations.
also is there.
Standard deviations.
Standard deviations.
Okay. So what conditions we can apply for using of this Z test? That is important. So we have basically we can observe three important points. One is first you should identify the sample size. Keep in your mind. Sample size should be large. That is n is greater than or equal to 30. Coming to second one is population should be normally distributed, approximately normal. Population variance should be known. Without known of these things, we can't apply this Z test.
So you are saying, sir, n less than 30 we did not apply for Z test.
Yes, exactly.
Why? Because large numbers only the value should be came in a
Yes.
goodness.
Yeah. So in that case, so we should remember this Z critical value table. Previous small sample test, we have a tables or appendix. So we'll give the last page of your textbooks or anywhere we can check the table based on the parameters and based on the degrees of freedom and appropriate test, whether true tail test or left tail test, the tables are available. But in the critical values we should remember. Okay. So level of significance. Already, what is the level of significance? The rejection regions. What is the rejection region? 1%, 5%, and 10%. So in that case, already if it is a two-tail test, why use the mod symbol? It's a two-tail test.
Always positive.
Always positive. Two-tail test provide the always positive. Mod values you can take. So if it is a two-tail test, Z alpha value, that means what is the Z alpha value at 1% level? 2.58. A student should remember this value. Examination point of view, these values are not provided. Student should be known these values. Okay. Two-tail test for 5%. What is the value? Z alpha is equal to mod Z alpha is equal to 1.96. Either 10% level is, what is the 10% level value? 1.645. This is comes under two-tail test. So right tail test value, Z alpha is equal to 2.33 and Z alpha is at 5% level is equal to 1.645 and Z alpha at 10% level of significance is 1.28. So if I consider the left tail test, Z alpha is equal to negative values. Left side is negative values only, na? Positive side, positive. Left side is negative values. So what is the negative value of 1% level? Z alpha is equal to minus 2.33. So at 5% level of significance, what is Z alpha value? Minus 1.645. So at 10% level of significance value is Z alpha is equal to minus 1.28. So number C1 value, it is a repeated value. Which value is repeated value? 1.645. Go back. So 1.6, that is either 10% and 5% left and right, positive and negative symbol.
These values is same values, they did not change.
Yes.
So in the critical region, they have to submit under root of Z CR value, critical region value, they have to submit their Z null for 2.58 or 2.68.
Yes.
What their values, they are directly substitute and the output
So
they have
compare,
to...
no. Compare with
table
your
value.
tabulated value, computational value.
Exactly.
So computational value and your table value.
Table value.
So then we make a decision. How we make a take a decision? You are asking the right question. I am going to explain the next steps. So there is a procedure of testing of hypothesis. That means basically the following steps are used to test the significance of a statistical hypothesis. Okay. So step number 1. Remember these steps. Total we have 7 steps. Step number 1 is collection of data from the given problem. Step number 2 is set up the null hypothesis, set up the alternative hypothesis and define level of significance. So set up the null hypothesis. Already you know the definition of null hypothesis. What is that? H naught, H0 is equal to mu is equal to mu naught, depends on.
So
there is
mu
no
is equal to
difference.
mu b.
Mu naught or mu b, whatever it, the symbol is denoted by textbooks. Generally we use population mean and normalized.
Exactly.
Mu is equal to mu naught.
Mu naught.
Okay, alternative hypothesis. Just now we discussed what is the alternative hypothesis. Students already know. Okay, so alternative hypothesis, you define alternative hypothesis. So these are the two important things. What is formulate the null hypothesis, formulate the alternative. That means setup. So after defining these two things, then we can further we are going to implement our testings. That is, after define the null and alternative hypothesis, you can use appropriate level of significance. At what level you are going to reject your hypothesis, null hypothesis. So then you define level of significance. So level of significance is represented by what? Alpha. So alpha is equal to use alpha is equal to 1%, 5% or 10%. Depends on the importance of the data. So now after use appropriate level of significance, now we can go for our suitable test statistics. So test statistic. Okay, use appropriate test statistic. Okay, that means based on the sample size. Already you know whether it is small sample test, whether you use large sample test. Use appropriate test statistics and use the calculation part and decide it.
Yes.
Okay, so after computing your calculation part, you are getting some tabulated value. Okay, after getting the tabulated value, now we are going to next step. Next step is what? Step number 6. We'll identify the critical value. Find alpha value at what percent level of significance? 1% or 5% or 10% level of significance at given degrees of freedom. Again one more question. What is the degrees of freedom? We are getting idea. So degrees of freedom means number of sample size. So depends on the two-tail test, right tail test. What is the dependent? Degrees of freedom, you know, degrees of freedom is equal to sample size minus 1. Depends on the test.
Free to choose the independent.
Free to choose the independent. That is a depends on the statistical test.
You have to use the critical test in step 6 only.
Yeah, step 6. After that, you will make a decision. Like the last step, 7 steps. So marriages are made in 7 steps now. So that is why you have to remember these 7 steps. 7 steps. Step number 1. Step number 7 is important step. So decision and conclusion. Yeah, this is 4 most important step. That is, compare calculated value with the tabulated value at the given level of significance. What just now we calculated the tabulated value, step number 6. Okay.
Exactly.
So step number 6 critical value. Step number 5 tabulated value. Okay. Now you have to already these data is available with us. Tabulated value available and calculated value is available. So how we will make a decision is important. This is most all people are confused here only. If I give one example, yeah, if the calculated value is less than or equal, calculated value using test statistic we have to data and calculate the test value. So now we are getting one calculated value. After getting that calculated value, just you compare with your tabulated value. So if the calculated value less than or equal to tabulated value at alpha level of significance, then accept the null hypothesis.
Yes.
Exactly.
Yes.
That is important key point.
The simple is always calculate value less than the table
Table
value.
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 Accepted.
Accepted.
Otherwise
Means what? If calculated value is greater than tabulated value at level of significance, at alpha level of significance, then we reject null hypothesis. Just I recall all the steps. Step number 1 is what? Collect the data. Step number 2 is what? Set up the null hypothesis. Step number 3 is alternative hypothesis. Step number 4 is level of significance. Step number 5 is test statistics. And step number 6 is critical value. And final step number 7 is critical value. And finally, we go for decision and conclusion. These are the four most important concepts in testing of
Of the
hypothesis. So, now after the remaining part, will explain by my co-partner Dr. Ramesh. I'll hand over to Dr. Ramesh. He will explain the remaining concepts.
So thank you, sir. So I am now going to explain the Neyman, Pearson lemma.
Sir, what is Neyman Pearson lemma? Where it should be used?
Yes, sir. So it is a most foundation theorem in statistics in testing of hypothesis. It's provided mathematical methods for finding the most relative rejection region. So according to Neyman Pearson lemma, it provides mathematical framework for finding the most powerful test between two simple hypotheses only. See that already Professor Raju explained. So in details the previous what are the testing hypotheses. So what is general null hypothesis, alternate hypothesis. So based on the statement of Neyman Pearson lemma is, so let K be any constant and W be the critical region of size alpha. Alpha is already known. This is called a type 1 error. So that is nothing but level of significance LOS. So then define W, X belongs to S, the ratio between L1 by L0 less than K, and the W complement nothing but X belongs to S, L1 by L0 greater than or equal to K. So where simple we know what is L0 and L1 is called a likelihood function of the corresponding sample observation. Yes. Given either maybe n observations, but under the simple under HO and H1, under only this simple. So then the main purpose of this lemma is, so you have to find the K, the value is K. So based on by using this called a alpha only, and also this W is called a most powerful. So test, this also called a best critical region. Excellent. So already Professor Raju is explained in detail. So what is the type 1 error? See this area is a type 1 error. So this is the rejection region, remaining is the accept region. So what is the best critical region? You have to going to find that value K. So based on our type 1 error.
Yes.
So that is called a alpha.
Yes.
See that here. So this method is 2 steps approaches. The step 1, first of all, find the K value, the nothing but critical region W value. Simple find out L1 and L0. So the ratio between L1 and L0. So you can find a critical value.
Yeah.
The step
L1
2
L2
is
or,
yes.
So
Yes,
what is L1 and what is L0?
That is the likelihood function of
functions.
corresponding under simple hypothesis.
Yes.
Exactly.
So under HO you can find LO, under H1 you can find L1 only.
Yes.
Okay,
Like
sir?
L1
So
and L0.
Yes, sir.
Yes.
After that step 2, this is very important. So you have to find the K value. K value by using our level of significance. See?
Yes.
Already we know alpha is nothing but probability of reject to the HO under H0 is true. That nothing but X is belongs to W under HO. So which gives this is the critical value. The rate is called best critical region of this value. Okay, the very
Ramesh
simple.
sir, critical.
Yes, sir.
So we have, you are discussing, sir, K value where we have found in the critical region only.
Yes, sir.
In
there
the
should be
critical
always
region.
K greater than 0 only.
Yeah.
So see that. So according now going to explain explain this example according to binomial distribution. We know one of the distribution discrete binomial distribution. We know so find the binomial distribution best critical region under HO is given theta equal theta naught against alternate hypothesis theta equal theta 1. The simple hypothesis only. Okay,
Yeah,
the simple hypothesis only.
Sir, Ramesh sir, the student know how they know. They have to apply their binomial distribution. How they can choose binomial, that is the binomial distribution or another Poisson distribution or an N distribution.
Yeah.
How they can find, sir?
He can give it, sir. X
condition
follows the
is-
binomial, X follows Bernoulli, X follows Poisson distribution. He can mention only.
Okay.
So it's very simple. The step 1, we know the probability mass function of binomial distribution. We know NCX, P power X, Q power N minus X, where X equals 0 to up to N. So the otherwise that is should be 0. We know. So first find out the level of significancy, nothing but, so what is here, correspond define, so and find out only L value, L nothing but called a likelihood function, now define L0 and L1, so define the ratio between, you can find the summation value, phi value, then should be greater than or equal to k, greater than or equal to k value. So now the ratio between these values, now taking on both sides logarithm, so both are logarithms, and you can apply this this only mathematical equation part. So this is that here sigma xi taking a logarithm. So now dividing by throughout this equation by n. So understood here, because see that here according to critical region, the x bar is given that b naught is always less than or equal to alpha. So whenever satisfy that property, we can find the value k. So that is why simplify dividing throughout this equation. So we get see that here. So this beta value. So this here the best critical region of this value is, so here x1, x1, the probability of maximum is under given, so x bar greater than b value. So this here b nothing but you have to find out, so b value, so b is based on given under simple, so it is applicable Neyman Pearson only, simple testing of hypothesis, whether it is HO and H1 only. So this is the based on this one, sir. So next one, another go to next example is one of the most another discrete distribution is called a Poisson distribution. See here, so x follows Poisson distribution. See that here, x follows Poisson distribution. We know according to probability mass function is e power minus lambda power x by x factorial. So under the simple hypothesis given, so HO is lambda equal to lambda naught versus or against H1 is here lambda equal to lambda 1. So now define the probability mass function, then find very safe step 2 is find out.
Here also we
Same,
define the null
same.
hypothesis and the alternate
Alternate
hypothesis.
only
Both the hypotheses we can
so
take
only,
that.
this is based on
Already
only
know.
simple hypothesis only.
So
Based on
Poisson
simple-
distribution is which type of distribution?
is the condition.
Discrete distribution.
Exactly.
Yeah, binomial
So
Poisson,
you know
discrete
this sir is explained the previous one also, both are discrete distributions.
Exactly.
So in the previous one here also we can take the probability mass function.
Exactly.
So what is the
PMF also
probability
take.
mass function of the Poisson distribution? Probability of x is equal to small x e to the power of
Minus lambda by lambda
for
power
x by x factorial.
Exactly.
So based on this, lambda is about parameter.
The
So
parameter.
this based on this parameter, we should define the formulate the hypothesis like null hypothesis and alternative hypothesis. Sir is explained like that only.
Sir.
So there is two hypotheses. One is null. So what is the null hypothesis statement?
At lambda
H0.
equal lambda
Lambda
naught.
is equal to
Lambda specified lambda naught
So H1 is equal to null hypothesis. Against means alternative hypothesis. What is that? H1 is equal to lambda is equal to lambda
1 only. Okay?
Exactly.
Yes. So it is also same. First of all, find likelihood function. We know the formula likelihood nothing but phi where I equal to 1 to n, because here samples are given x1, x2, so on xn only. Okay? N sample random one drawn from, so corresponding sample size only. Then e power minus lambda power x by x factor. Then apply the mathematical part. Then apply the formula lambda 1 by lambda naught greater than or equal to k. So now we know already L1 based on this H1. Already we know the LO based on HO. The simplify this is now taking on same both side logarithm. So simplify, now convert into sigma xi is common value, log some values, dividing by n, we get x bar. See that here x bar is always greater than or equal to this b. So b is going to how to find out. So this b is called a such that is called a probability of the given x greater than or equal to b. Whenever always HO is true, it is always less than or equal to alpha. This alpha is our satisfy the maximum probability occurrence. So that is we have to find the beta value. Beta is based on this one. So this is the best power test of this one only. Okay, sir. So this is called general example. So another one numerical example. So it is here. Suppose x is a single observation samples of population with the corresponding PDF is given f of x equal theta and x power theta minus 1. The range of x is 0 to 1. Find the test of the best critical region BCR and also find the most powerful test with level of significance is suppose alpha equal to 0.05 and testing of hypothesis nothing but here under h0 theta equal to 3 and h1 theta equal to 2. See that given in previous problem is not mentioned. So already Professor Raju said, so lambda equal lambda naught. So here lambda equal lambda 1. Here given here 3 theta equal to 3 and theta equal to the numerical problem. Here also same concept, the given function is given f of x equal theta into x power theta minus 1. Then find likelihood function. Then lemma is find the most powerful test. Then L theta 1 divided by L theta 1 greater than k. So here theta 1 nothing but corresponding to. So that is why theta equal to 2. 2 into x power 2 minus 1 divided by 3 into x power 3 minus 1 is greater than k. So simplify, we get see that here x is less than or equal to 2 by 3 into k some value. So this is let's suppose k star or any symbol we can use b star whatever b value. So this let us simple understanding here k star value. So k star nothing but this is the lemma tells us the form the rejection region the most powerful test is nothing but say w equal to x such that x is less than k star. So now the k star is now going to find is very important. So this is on the basis of our target is you have to find the k star sir. See that such that here the critical region is alpha equal to 0.05. The mention is here alpha equal to 0.05 hence alpha equal to probability of x belongs to w given that h0 is true. So all these alpha value is given 0.05. That is here see that here x belongs to w. So nothing but up to k star value the probability of x less than k star whenever under h0 theta equal to 3. See here. So already we know this is the probability density function is given. So that is here that 0 to k star. So this value is 3x square dx. Now simple integrating with respect to x. So that equal to 0.05. So now simple we know in integration. So substitute value then we get k star value some 0.38. So this is the according to Neyman Pearson lemma tells that the rejection region of the most powerful test is x less than 0.368. So this is our target. We have to find out the k value. So this is the one of the most application of this is values.
So in that case, we are taking the 0.368 is the best critical region.
So that
so
is
based on that, we'll going to reject the best critical. We find out this region, the critical region.
Yes,
so your according to our question, our best critical region is 0.368.
So and also another one problem I can explain.
So now, so he wants to explain one more problem regarding the Neyman Pearson lemma.
Yes.
Okay, lemma. So in that case, lemma
I can
is
explain suppose here. Suppose simple example
Bernoulli. So Bernoulli distribution.
So they will ask the in the
Distributions.
Bernoulli distribution through Neyman Pearson
Yes,
lemma.
yes.
So that's only they can apply that for Bernoulli distribution or binomial distribution or Poisson or anything.
Either any normal distribution also.
They can also.
Continuous case also.
So this is the better distribution case. So better. So can you explain that Bernoulli distribution example also now?
Yes, sir. See that here, this another simple. We know Bernoulli distribution. The Bernoulli distribution is one of the discrete distribution. It takes only two possibilities. Whether x equal to 0, x is equal to nothing but here. It is two possibilities, success and failures. Let us suppose x1, x2, so on, xn are IIDs. So here independent random variables Bernoulli. The parameter suppose here p. We know the probability of success. So under H4 p equal to 0.4 versus H1 is p equal to 0.5. So by you see that given the parameter values. So according to Neyman Pearson lemma, so define the likelihood function. We know the probability mass function of Bernoulli p power x into 1 minus p whole power 1 minus x. 0, 1. So the two possibilities. Okay. See that here you can apply the likelihood function of L 0.7, L 0.4. Now dividing this throughout this equation. Now rejection H0 for for these large values of sigma xi. So this is nothing but according to MP test is the rejection H naught when the sigma xi is always less than or equal to k. So this is very simple, the for large values always is nothing but less than or equal to c. This is the one of the most important concept in that is called in testing hypothesis is called a Neyman Pearson lemma. The most important. So this any doubts in this case? So
Continue, sir.
yes, sir. So this is the one. So and also simply already explain this here. So similarly example for same in normal distribution also. Suppose let us go for continuous distribution. Normal distribution very important. So here we know simple probability mass function normal distribution. The f of x equal suppose here 1 by root 2 pi e power minus 1 by 2 x minus mu sigma whole square value. So we know this already, we know mu value and sigma value.
That is also one of the important distribution. That is a
So similar process.
yeah, that is a probability density function.
Yes, sir.
So,
So
in the
under-
density function, so what is the range of the sigma? What is the range of the mu? Also
Yes, sir.
important.
The sigma is greater than zero.
Sigma square is always greater than zero. Mu is lies between minus infinity to plus infinity.
yeah.
Sigma square greater than 0 is mandatory.
Mandatory, because f of x is equal to 1 by 2 root
Root
pi
2 pi
sigma,
sigma.
Exactly.
into e to the power of x minus mu by sigma whole square.
Exactly.
So that is why if the it is only positive, then only function will be
Satisfy
defined,
the positive
satisfy
one.
the property.
Exactly.
Yeah.
So this is
that
also same according to first of all define the simple hypothesis. Under H naught suppose theta equal to theta naught versus or against theta equal to theta 1. So according to simple hypothesis, so now define same as it is likelihood function. So L value, so L0, L1 by L0.
Likelihoods.
Then same. So find the likelihood functions. The ratio between likelihood function.
Always
Then simplify.
this always greater than
Greater than or equal to k, greater than k, you have to find the k value.
Yes.
So k depending on given level of significance.
Level of significance.
If not given level of significance, just you have to find the convert into x bar formula in terms of beta. Same as mathematics explanation. So taking on both the logarithms. So then simplify, get the value in this between. So now x bar, given that beta is always less than or equal to alpha. So this is the test procedure to find the most powerful test of this nothing but according to Neyman Pearson lemma.
okay. Right.
Yes, sir.
Vijay.
Raju sir, what is unbiased critical region?
So unbiased critical region.
This also nothing but the probability of maximum occurrence of x1, x2, so on, so x1 is less than or equal to corresponding alpha. So alpha whenever satisfy this level of maximum less than or equal to alpha, that is called a unbiased value.
So this is 1 minus beta,
Beta.
less than alpha also
Alpha
as an unbiased critical
yes,
region.
yes.
So we can utilize the critical region
that-
said to be unbiased critical region x1, x2, xn that belongs to C, whatever earlier told.
Yes, yes.
So 1 minus beta less than, we can take that the unbiased
It is
critical
nothing but
region.
power test only.
Exactly,
The power
sir.
test is nothing but 1 minus beta is
Power-
less than or
1
equal to
minus
alpha.
beta, already I said the definition. Power of the test. 1 minus beta is tells about what? Power of the test. So based on the 1 minus alpha, we'll go for us.
Is the list.
1 minus beta greater than or equal to alpha, it is a unbiased critical region.
Right,
So
exactly.
Raju sir, what is test function name on Pearson lemma?
So randomly means we can take the ratios.
Exactly.
Ratios, based on the ratio, we can take the randomly take the ratios L0 and L1.
Exactly.
So based on that, we'll find out the unbiasedness.
So L1 by L0 is a maximum when x is equal to 5 we can take, sir?
Yes,
Yes, we take also.
We can take maximum only. Maximum is provide the better
Exactly.
value, value.
So L1 by L0 we can take the maximum x is equal to 5, then only we can take the random test function.
Yes, these are the completely Neyman Pearson lemma and its properties.
So suppose Raju sir, we told that x is equal to 5. Suppose we can take, we include the point x is equal to 4, L1 by L0.
Yes,
What is the highest value we can write, sir?
highest value we can take
C2
the
is equal to 4, 5 we can write it?
right.
Yes, yes.
No
We
issue.
can write it
No
the
issue.
4 comma 5. So
4
highest,
comma 5.
you told that the highest value is 5. So we can take that the 4 value taken that C2 is equal to 4, 5.
4, 5.
3 taken that 3, 4, 5 we
3,
can
4,
write
5.
it.
4 is the maximum value in that case.
Exactly. Random test function also we can
Yes.
take that values
Yeah.
here also.
Yes,
Yes.
So consider C1 is equal to 5 also the best critical region.
Yes.
So also
Consider
the
the
maximum along the critical region
Yeah.
by z less than or of alpha we can take that values also
Yes,
here.
So that
Clear.
is the most important. The main purpose of this only, W is the most powerful test.
Yeah, these are the today's sessions. Okay, so any doubts Any students is asking the questions regarding any sessions?
No.
Did you receive any phone call? No. So once
we
again,
have to discuss. So there is no calls here. So the randomized test function Raju told, the suppose of phi of x bar r power n stands to 0, 1, we can take the function defined. The closed interval 0 also. So we reject new hypothesis. Am I correct, sir?
Yes, exactly.
We reject the new hypothesis h0 with the probability of x, and we do not reject ho with the probability of 1 minus phi of x.
Yes, exactly.
So why? Because 1 minus, what is the difference between the phi of x and 1 minus phi of x, sir?
So just now we discussed power of the test.
Power of the test.
Exactly.
Power of the test. What power of the test is explained about 1 minus beta. 1 minus beta is what? Type 2 error.
So
Beta
NP lemma is the randomized test function, sir.
Randomized test function only.
So phi of x square randomized test function is we can take that here only.
That is nothing but 1 minus beta is nothing but probability of x belongs to w when given that h1 is true. That is
Exactly.
nothing but only. This is nothing but 1 minus beta is less than or equal to alpha. Whenever satisfied, that is called the Neyman Pearson lemma. These are nothing but.
Sir Raju sir, if we can type 1 and type 2 error we can use in the concept of testing of hypothesis.
Yes.
So this type 1 and type 2 error using NP lemma also?
Yes, exactly. We
that
can
based
find out the committee best errors. How to find the errors based on these tests only.
This NP
So
lemma test.
committing type 1 error, type 2 errors, we can estimate that how much error will made. A person will made based on the, if you know the rejection, 1 minus alpha, beta, alpha value we need to find, beta value we need to find. If you know alpha and beta value, we need to find the power of the test also.
That is the size of the critical
Size
region.
of the critical region. This will,
That
all
is
this
based on
comes
only
under
critical region.
critical region. This is a base, everything is comes under best critical. That is why we need to find the best critical region by making use of Neyman Pearson lemma.
So type 1, type 2 error is mandatory to use in the Neyman Pearson lemma. Then only we can take the results.
Yes, alpha is the main based on alpha.
Alpha is the major, play the crucial role or critical role finding the best critical region.
So in the randomized test function, Ramesh sir, phi of x is equal to 1, suppose we can take that.
Yes.
So x greater than x less than 4.
Okay, is x less than 4 only.
So phi of x is equal to 1, x greater than 4 or less than 4. So students they can take that 5, 4, 3, 2, 1.
Yes.
So the critical region and also the randomized test function
Yes.
they can do
You can
here.
do it.
Yes.
See that once again, just to brief this Neyman Pearson lemma, this is based on only two-step approaches. The step 1 is you have to find.
Sir, one objection, sir. Two steps approach. There is no one step approach is there.
No. Compulsory you can apply only two steps.
Two
approach
steps.
only.
That is 2 steps again re-explain to
Yes,
our
yes,
students,
yes.
sir.
Just only first of all find out likelihood functions corresponding simple hypothesis under H2 and H1. Then ratio between L1 and L0 is nothing but greater than or equal to K. So that is called a critical region W. So after completing critical region, now you can find the K value based on only given level of sigma. Level of significance nothing but alpha percentage. If that only, that is called alpha equal to probability of x belongs to W when H0 is true. So which gives the best critical region. So based on these 2 steps, most important. The student should be simple. Remember these 2 steps only.
Sir, Neyman Pearson lemma is used to determine the best critical region.
Yes,
Yes,
As
that
per
is the
our-
main aim of the doing test is best critical. We should find the best critical region.
Yes.
Sir, so thank you very much, Professor Raju garu and Dr. Ramesh garu. A good explanation for our students for Neyman Pearson lemma and the concept of testing hypothesis. So in this one, the composite hypothesis, null hypothesis and critical region, type 1 error and type 2 error, Neyman Pearson lemma problems. In the Neyman Pearson lemma, you have used the binomial, Poisson or anything. What they have asked the
Even continuous also.
yeah,
normal
continuous or normal
uniform.
distribution also
uniform
the formula
exponential.
should apply and they can solve the problems. And the critical region and the random test functions, the students may learn the good steps. Thank you, sir. Thank you one and all.
Thank you.
Thank you, sir.
Thank you.